Swayam Prabha. Digital India. Educated India.
So, last class I have discussed few methods by which we can determine the settlement of granular soil, and I discussed 4 methods, that is based on SPT, then plate load test, then SCPT. Actually, I have discussed 3 methods to determine the settlement of granular soil. Now, today I will discuss the remaining 2 methods. The fourth one is the semi empirical methods, which is similar to that consolidation equation problem or consolidation problem. So, where every layer, that means if we have a number of layer or granular layer. So, this is the foundation. So, and this is layer 1, layer 2 and layer 3. Which is same as we did for consolidation settlement case, or we did for the settlement or granular settlement determined by the SCPT test or STPT test data. So, that means we have to take a point for on middle of the each layer from the base of the foundation up to the influence zone. As I mentioned, the influence zone for settlement calculation is 2 times the width of the footing. So, suppose if the influence zone is up to this, so this is the influence zone, then this will be the 3 different points, as there are 3 layers. And I have already discussed that you can divide one particular layer into number of layers and take the points at the middle and then do the calculation. But in this example problem or this course, I will take only one point at the middle of the each layer, and this is the 3 points, that's A, B, C, and this is up to the influence zone, and every point we have to calculate the del P and sigma 0 bar, effective overburden pressure and the increment of stress due to the application of load. Okay, and as I mentioned, del P we will calculate by 1:2 distribution, and effective overburden pressure we will get at different points. And then first each layer we will calculate the settlement for each layer, and then we will add the settlement of all the layers, and you will get the total settlement of the foundation. So, this is the total settlement we can get by summation of settlement of each layers. And E is the elastic modulus of the soil layer, and I have also given you the tables by which you will get the elastic modulus of the particular soil, but it is better to have the actual E value for that particular soil. But if you do not have the actual E value, depending upon the type of soil, you can also select the appropriate E value by using the tables that I have given. Okay, so, next method is the strain influence factor methods. So, this methods was proposed in 1978. So, this is the expression. So, the S means the settlement is the C1 C2 into the Q bar, here is the stress acting on the foundation base, and Q is the gamma dF, and gamma is the unit weight of the soil, dF is the depth of the foundation, and delta Z here, this is the thickness of each layer. Okay. So, in previous equation it is given H, which is also thickness of each particular layer. Here it is written in different form, it is delta Z, that is also thickness of different layers, and then we have to integrate, we have to take the summation for 0 to Z2. Now, I will give you that what is Z2, and then here two correction factors are given, a correction factor for the depth of foundation. Okay, I mean this is the depth correction factor and the correction factor due to creep in the soil. So, that means two correction factors are proposed, one is due to the depth of the foundation, another is creep, due to consider the creep effect of the soil. So, these two foundations, these two correction factors C1 and C2 can be calculated that by using these expressions, and these expressions, this time is in years divided by 0.1. So, now what is Z2, and suppose, and how I will get the Iz, that is the strain influence factor for a particular foundation. So, suppose if we have a loading of this is the ground surface, okay, and we have a foundation, say now the foundation can be at any depth also. Here I am just drawing the foundation, and you consider this is not actually the surface, it is actually the base of the foundation. This line represent the base of the foundation. Okay, and that is z equal to 0. Now, if this is say center line of the foundation or the loading area, okay, and we have two different z values given, one is z1 to draw the influence line, one is z1, another is z2. Okay. So, here also the summation is given up from 0 to z2. Okay. So, now how I will decide the z2, because this is my z1 value and this is z2 value. Now, corresponding to z1, this is I am drawing a line. So, this influence line or influence factor we will get by using this line. Okay. So, that means your Z2 will also extend up to this point. Okay. So, now how we will get the Z1 and Z2 and how we will get the Iz value. So, now the Q is that suppose if df is the depth of foundation, then there is a term Q. Now, Q is equal to gamma df, gamma is the unit weight of the soil, and Q bar is the stress, this is basically Q bar, that means that is the stress at the base of the foundation. Okay. So, that means here you consider at the base of the foundation, that means at the base of the foundation the net pressure that is acting is Q bar and Q is the gamma df. Now, this is the influence line Iz line, and how I will get the Iz value. Now, this is width of the foundation and Z0 is not at the ground surface, Z0, Z equal to 0 is at the base of the foundation. Now, here this is the line and I am giving the value of Z1 and Z2, that for Iz value we will get equal to 0.1 at Z equal to 0 and equal to 0.5 at Z equal to Z1, that is equal to B by 2, okay, and equal to 1 at Z equal to Z2, that is equal to 2B. Okay. And this is for square or circular footing. So, that means for square or circular footing, Now, your actually Z2 is basically the influence zone that is considered during the calculation. That means, as in my previous settlement calculation problems, I said that the influence zones from the base of the footing you have to take twice B. So, here also for it is taken up to twice B, but that is for square or circular footing. So, now that means this Iz value will increase with depth up to a certain depth, then it will decrease. Okay. So, now how this Iz value will be calculated? So, Iz value will be calculated, sorry, this is not the, because this should be 0, because it will increase, then it will decrease. So, this is 0. So, this is not 1, this is 0. So, that means it will start from point 1 at the base of the foundation, then it will increase and increase up to Z2, which is half of B 0.5, then again it will decrease. Okay, so, that is the influence line which is proposed, and then it will be equal to 0 at the influence zone, up to the influence zone. So, that means Z equal to Z2 will be at twice B, where the Iz equal to 0, and it will start from 0.1, and then this value is 0.5, which is Z1, and that is B by 2. Now, for the if your foundation L by B is greater than equal to 10, then Iz, so this is greater than equal to 10 means is strip footing. So, for strip footing it will start with 0.2 at Z equal to 0, then it will be maximum at Z equal to Z1, and that is equal to B. Okay, and this is 0 at Z equal to Z2, and that is equal to 4B. So, that means again the maximum value is 0.5, but only the starting value here is 0.2, and now the influence zone is more in case of strip footing compared to circular or square footing, which is also true, because it is been observed that the influence zone of strip footing is more than the influence zone of square footing. So, that twice B I am talking about, that is the actual influence zone for a square footing. When for strip footing, the influence zone is taken as 4 times of the B. But for this condition you have to use for this particular problem, but in general way for any type of footings you can consider a influence zone up to twice B for other problems like consolidation problems or the methods that I have discussed, where the influence zone is required. So, this particular case you consider for strip footing it is 4B, but for square and circular footing it is twice B, but for other problems you consider the influence zone is twice B for the settlement calculation and B for the bearing capacity calculation. So, this is the general rule that we will follow, but actually you remember that for the strip footing your influence zone is more compared to the square footing. So, that means if your L by B this value increases from 1, that means for 1 it is twice B, now it will increase from 1 to say 10, that means at 10 it is considered as 4 times of the B. So, if you increase it from 1 to onwards towards the 10, then the value will increase. It is not twice B, it is more than the twice B, but in general term we consider the influence zone for settlement is twice B, but in this particular problem you have to take twice B for circular and square and 4 times of the B for your strip footing. Now, I will solve one example problem for this particular case. So, for this particular case your footing is square footing, okay, and which is dimension is 3 cross 3 meter square, Now, load is acting on the footing which is 1800 kilonewton, and unit weight of the soil is 18 kilonewton per meter cube. Again, remember that when you calculate the gamma df, then you consider the effect of water table if it presents, but now here it is not present. So, that is why we will not consider the water table effect. So, that is why the unit weight is same throughout the soil, and that is 18 kilonewton per meter cube, and depth of the foundation df is 2 meter. So, as I mentioned, so we need q bar and q. So, q will be gamma df. So, this is q, gamma is 18, df is 2. So, that is 36 kilonewton per meter square, and the q bar, which is the net pressure which is acting at the base of the foundation. So, that in the net pressure, the total force divided by the area. So, the total force is 1800 divided by the area, which is 3 cross 3. So, this will be 200 kilonewton per meter square. Okay, so now the C1 expression is given. The C1 expression is given, that is for the correction due to for the depth of foundation with 1 minus 0.5 q divided by q bar minus q. So, that means the C1 is equal to 1 minus 0.5 q divided by q bar minus q. Okay, and that is 1 minus 0.5, q is 36. Then q bar is 200 minus q is 36. Okay, that is why C1 is 0.89. Similarly, the C2 value is, the expression is given, that is due to the creep of the soil, that is 0.2 log 10, that is T in year divided by 0.1. So, that is the expression is given, that is the 1 plus 0.2 log times in year divided by 0.1. So, now for this case we are calculating the settlement for 1 year. Okay. So, calculating for the settlement for 1 year, and that is 1 plus 0.2 log 10 divided by, it is in years, 1 divided by 0.1. So, settlement at 1 year. You can calculate for lesser time also, but I have taken 1 year. So, and you can calculate for higher time period also, but as it is a immediate settlement for the granular soil. So, if you increase the time, that not much variation will happen. So, that means this is 1 plus 0.2, oh sorry, I have written that. So, the value which is coming is 1.2. So, now the C1, C2 correction factors are determined. Now, the next step is to determine the IZ value. Okay, so, now we have this foundation. So, this is the base of the foundation, okay, and here it is considered as z equal to 0. And then this foundation, it has 3 layers. So, this is the layer number 1, this is the layer number 1, this is the layer number 2, and this is the layer number 3. So, this is layer number 3, layer number 2, layer number 2, and this is layer number 1. So, this df is 2 meter, and this load P is acting as a 1800 kilonewton. Now, depth of foundation, suppose this is the ground surface. Now, depth of foundation is df is equal to 2 meter. Now, thickness of this layer is say 3 meter. So, layer 2 it is also 3 meter. Okay. And there is a layer 3. So, layer 1 is 3 meter, 2 meter is depth of foundation. So, the thickness of layer 1 below the base of foundation is 1 meter. For 2 layer it is 3 meter, and it is a square footing whose dimension is 3 meter. So, the influence zone will be up to, for the square footing it is influence zone is up to twice b. So, it will be 6 meters from the base of the foundation. So, it is 3 plus 4, then another 2 meter will be on third layer. So, that was total twice b, b is 3. So, 6 meter from the base of the foundation. So, 1 meter will be on the first layer, 3 meter will be on the second layer. So, this is 3 and 4, remaining 2 meters will be on the third layer. So, now I have to draw the influence line, and that is for b by 2 and b is 3 meter. So, at 1.5 meter, so this is 1 meter. So, that 1.5 meter this value will be more. So, it will start like this and then it will end like this, and this is your 2 meter basically. Up to this point it is 2 meter. Okay. So, now this point, this is 0.5 and this is 0.1 because it is a square footing. So, now let us calculate. You take the name of the different layer and then del z. Del z is the thickness of each layer, then EI, okay, and then this ZI, ZI in meter, okay, and now EI value for every layer also given. So, EI E1 is 15,000 kilonewton per meter square, and E2 value is given, that is 20,000 kilonewton per meter square, and E3 is given as 40,000 kilonewton per meter square. Okay. So, I am writing E3 in this side. Okay. So, E3 is given E3 is given 40,000 kilonewton per meter square. Okay. So, E3 value is given 40,000 kilonewton per meter square. So, now what are the things are given? That means the dimension of the footing is given 3 cos 3 meter. What is the amount of load is given 1800 kilonewton per kilonewton. Then unit weight of the soil of the first layer is given. So, that is unit weight of the soil of the first layer is 18 kilonewton per meter cube. For the other layers it is not required, that is why it is not given. You can also, that means all the soil properties can be given. So, DF depth of foundation is 2 meter, which is given. Then the time at which I want to calculate the settlement, that is 1 year, that is also given. Then the thickness of every layer is given and the properties of the layer, each layer, and the properties which is required is elastic modulus. So, elastic modulus of all the layers are given, that is 1500 1000 kilonewton per meter square for first layer, then 20 MPa for the second layer and 40 MPa for the third layer. So, now I will calculate the for the layer 1, layer 2 and layer 3. Okay. So, layer 1, what is the thickness of the layer from the base of the foundation? First layer thickness is 1 meter, because that is from base of the foundation. Second layer thickness is 3 meter, and third layer thickness up to the influence zone, that is Z2 is equal to 4b is 2 meter. Now, EI value is for the first layer it is 15,000 kilonewton per meter square. So, this is 20,000 and this is 40,000. Okay. Now, we have to calculate the influence factor for every layer. Now, where we will calculate? Suppose this equation there is a summation, and then where we will calculate all this influence factor IZ. So, we have to calculate the middle of the each layer. We did the same thing for other cases also. We calculate the effective overburden pressure or the stress increment at the middle of the each layer. Here also we will calculate at the middle of the each layer, and that is Zi. Zi is the middle of the each layer. So, from the base, because everything we are calculating from the base, where base is Z equal to 0. So, base is from the base, the middle of the first layer will be 0.5, the thickness or the distance from the base to the middle of the first layer is 0.5, because the thickness of the first layer is 1 meter. Now, for the second layer it will be 1 meter plus 1.5 meter. So, it will be 2.5 meter. So, for the third layer it will be 1 meter plus 3 meter plus 1 meter. So, it will be 1 meter for the first layer, then 3 meter, second layer 4 meter plus the middle layer, middle of the third layer. So, that is 1 meter. So, it will be 3 and 2, 5 meter. So, now I will calculate the Iz value, that is at the, this is middle of the layer, that is also at the middle of the layer. Okay. And here I will calculate Iz divided by Ei into del Z, which is meter cube per kilonewton. What we are doing? We are basically calculating this part, that is Iz by E into del Z. Okay. And then we will add them, and then we will multiply with these factors and this Q value, difference of this Q. So, that means here, remember that here the addition is only this portion, and in the previous addition is total addition, and definitely that 2.3 will go outside. So, other parts we have to add, but here the addition is only for this portion. So, then Iz at the middle, that means here this is my middle portion. Here this is the middle portion, this is the middle portion, here this is the middle portion, and here this is the middle portion. So, what we have to do? We have to linearly interpolate these values, and we will get the Iz value, because this is the Iz line. So, I know this at Z equal to 0, Iz is equal to 0.1. At Z equal to this distance will be this is 0.5, this distance is 1.5, this is b by 2. So, at 1.5 Z equal to Iz equal to 0.5. So, then I can get what is the value of Iz at 0.5. Okay, I know that at 0 and at 1.5, then I can linearly interpolate this value, and I will get what is the value of Iz at 0.5. So, that value at 0.5 I am calculating. So, by linear interpolation. So, that means here for first layer Iz value is 0.133. So, because this is 0.1, this is 0.5. So, this value at 0.5. So, this distance is at 0.5, this is 0.5. So, this 0.5 it is 0.133. For layer 2 at a distance here, which is 2.5 from the bottom. So, or from the top, from the base of the foundation at a distance of 2.5 meter. So, here at 1.5 meter it is say 0.5, at 6 meter it is 0. So, again by linear interpolation I will get what is the value at 2.5 meter from the base of the foundation, and that value is 0.389. For third layer is 0.111. Okay. So, Basically just for similar triangle you can determine, you know that how to do the linear interpolation, because this is for the this triangle, you know, at this portion you take this triangle, this lower triangle, and then you will get the iz value corresponding to these dotted blue lines by linear interpolation, and that is the iz value for the second layer, and this is the iz value for the third layer. And then we will add them, and addition we will get 8.87 into 10 to the power minus 6. The addition of these factor, I mean, then we once we get the iz, then I know the del z, then I know the ei. So basically this column is iz del z divided by ei for each layer, okay, and that is 5.84 into 10 to the power minus 5 and 5.55 into 10 to the power minus 6. So if I add them, then this will be 7.28 into 10 to the power minus 5. Okay, 7.28 into 10 to the power minus 5. Why we are adding them? Because we have to add them for each layer. Now the final settlement S will be equal to your C1, C2, Q bar minus Q summation of iz del z and ei. So that means C1 is 0.89, C2 for one year is 1.2. Now the Q bar is 200 minus 36, 200 minus 36 into 7.28 into 10 to the power minus 5. Okay. So this means this settlement is coming 12.75 millimeter. Okay. After 1 year it is 12 point, after 1 year. Now after 5 year, the similar way you can calculate, only difference is you have to change the C2 value, because it is considered that is the creep. Okay. So it is, remember that why we are considering that 1 year and 5 years and 10 years, you can say that this is the immediate settlement. Why we are considering the that much of time, I mean 5 years or 1 year, because it is due to the creep. This C2 effect is due to the creep of the soil. So that's why, and creep is a time dependent phenomena. Okay. So that's why you are checking what is the additional settlement due to the creep. So after 5 years, this value is 14.24 millimeter. Okay. So that means not much variation is there, and most of the settlement will got that very short duration, because it is the immediate settlement, and then due to creep there will be some increment of the settlement, and you can see that after 1 year that is 12.75 millimeter, and after 5 years it is settlement is 14.24 millimeter. So that means this is the procedure, and you take the different layer, then draw the influence line depending upon your foundation, then at the middle of each layer you calculate the iz value by linear interpolation, because you know the values of two endpoints and you know the distance. So you will get the iz value at those points, then add them all the iz and this term, add them, then multiply the other factors, you will get the settlement at respective year. Okay. So this is the, I have discussed the different settlement methods by which you can determine the settlement for clay soil as well as the settlement for granular soil. So this the method that I have discussed, so as per my suggestions, you should use these methods for this particular soil that I have discussed. That means the two methods, for one is for immediate settlement of clay, another is for consolidation settlement of clay, then the rest of the 5 methods for granular soil. So next class I will discuss the next topic, which is the beams on elastic foundation, because here we have discussed bearing capacity and the settlement, and these are two design criteria, but here we have not considered the interaction between the foundation and the soil, and we have concentrated mostly on bearing capacity and the settlement. But in addition to that, we also need the bending moment and shear forces to design the foundation. So, how to calculate the settlement, then the bending moment, slope or shear force of the foundation considering soil foundation interaction. So, that I will discuss in the next class. Thank you.